Hello, lovely people. You're welcome to another video on additional mathematics. In today's lesson, we are going to introduce logarithm and exponential functions. So this is my worksheet that I've compiled from 2020 to 2024. Um, this worksheet will really help you to understand logarithm. Now we are going to start with the concepts. When you are learning, the concept is very, very important. It's like your tomatoes, onions, oil if you are preparing your stew. All right. So now in the concept, we are going to look at what logarithm is. Now, when you talk about logarithm is simply a function that can be written in the exponential form. Okay, a function that can be written in the exponential form. All right. So now the number here or the letter here is called the base. This is called the argument. That's the expression that the function works on, the logarithm function works on. And this is the power, or what many people call the exponent. All right. Now we learn from indices that the base carries the power, right? And this will give you your value. The value here is the argument, okay, or the expression that the logarithm acts on. So now this one could be written as base carrying the power, okay, and is equal to the argument. Is that not simple? So if I have log m to the base b, have you seen I'm reading it log m to the base b, or this one could be read as log to the base b of m. Okay, now this one is equal to, imagine they say this one is equal to n. I should write it in the exponential form. It is simply the base will carry what? The power. The base carries the power, and this one is equal to m. Is that not simple? Very simple, eh? There's nothing difficult here. So if I have 10 to the power 2 is equal to 100, I can express this exponential form to the logarithm form. I'll just write logarithm log. What is the base? The base is 2. What is the power? The power is what is outside, eh? And this is the argument. And if you want to check whether it's correct, the base will carry what? The power. Very simple. What about if you have something like this? You are being told to write this one in the logarithm form. This is your base, that's your power, this is your argument. Very simple. There's nothing difficult here. Logarithm happens to be one of the simple topics in additional maths. Whenever I tell students, they don't believe, but it's true. All right. Now let's look at the laws of logarithm. Some book call it rules of logarithm. They are the same. Now the first one is called the product law. The product law. Now it says that if I have logarithm of, let's say two expressions m and n multiplying. Okay, and then let's say the base is b. Now this is the same as log m plus log n to the base b to the base b. Both of them will have the same base. So if your arguments are multiplying, you come and add your log expressions. Please take note that this is not the same as, let me use a red ink so that you remember it forever. This is not the same as this. Okay, it's not equal to, please, so don't make this mistake. What's the difference here? You can see here your arguments are multiplying, but here your argument expressions are adding. Please, it's not the same. Many students make errors with this one, so please don't make this mistake. All right, let's look at our second law, the division law. Division. So you have m divided by n. Now this is the same as log m to the base b minus log n to the base b. All right, is that difficult? I think it's very, very simple. Okay, now please take note also here that this is not the same as m minus n. It's not the same. Okay, please, a lot of students make this mistake. It's not the same. So that's the division law. Let's move on to another one. Um, this is called the power law. Power law. So let's say you have a logarithm of m to the base b, and that our argument here is m, right? Let's say the m is raised to a certain power. Now the power here will jump down. Say jump down. Yes, the power will jump down and become your coefficient. It becomes the coefficient of your logarithm. All right. So this is what we call the power law. Example: if I have log 5 to the base 2, and that 5 has been raised to the power, let's say to the power 2, or let me make it base 3. So now this one, the power will what? Jump down. So you have something like this. Now please take notes. Let me make a quick disclaimer that log this one is not the same. It's not the same as this. Now I want you to pause the video for 1 second and tell me what the difference is. As you can see here, the whole logarithm, the whole function is being squared, but here just the argument, just the 5 is being squared. That's the difference. So now this one means This one is equal to log to the base 3 of 5 is the same as that logarithm multiplying itself. Okay, so please take note. It's multiplying itself. And the other one, I've written it here. The other one is just the argument that's being squared. So that one, the power will just come down. All right. So can we move on? Now we have another one called change of base. Change of base. You know, you can change the base of your logarithm to any base that you want. Example, I have been given log b to the base a. Then I'm being told to convert this one, convert this expression, convert to base c. Very simple. Do you know what you do? You just write logarithm as your numerator, logarithm as your denominator. Then write b here. That's the argument over the base. Argument over what? Base. Then you just, what are you changing it to? You're changing to base c. So you just write c here, c here. Is that not simple? Let's take another example. What if you have the same log b to the base a? We are converting to, we are converting to base. We are converting to base b. Okay. Now, if you are converting to base b, the same idea. You write logarithm, numerator, logarithm, denominator. Then, what is the argument? The argument is b. What is your base? Is a. What are we converting it to? You are converting to base b. So b will be here and b will be here also. So this is the same as 1 over log a to the base b. I have not told you, but look at the numerator. Any logarithm whose argument is the same as the base, argument is the same as the base, is 1. So logarithm of an expression to the same base is what? 1. Hope you'll be able to keep that in your head. So it's important to note that whenever you have log b to the base a, this is the same as 1 over. Then you just swap the letters, okay, or the expressions. So people have made this in a formula, but that's how you got this. So that's how you got this. So now let's take row number example. I have log 5 to the base 2, and I'm being told to convert to base 3. So this is how to do it. You write logarithm at the top, logarithm down, your argument first, then your base follows. Then what are you converting to? You're converting to base 3. So you just write 3 here, 3 here. That's it. No difficult, right? So you are done. Let's take another example. Now this time I want you to pause the video and try it yourself. You have log 3 to the base x. Now this is the same as I'm converting to base, convert to base 3. This is the same as log 3 over log x. What are you converting it to? Base 3. 3. So this is the same as 1 over log x to the base 3. Okay. So what people do is that when they are converting to, let me give you an example of what I'm saying. When they are converting to let's say base 3, you say, yeah, you're just going to swap your base and your argument. Okay. If they say convert to something that is your argument, you just swap them. So people just swap. So the base becomes 3 and your argument becomes x. Okay. So this only holds if the argument is what you are converting to. All right. But generally, this is the formula. So let's move on with more properties. Now, log m to the base b. Now, this is the same as before you can solve this one. This is your argument. Your argument must be greater than 0. That's before you can solve your logarithm, or for your log function to be defined. To be defined, your argument must be positive. Okay. So in other words, before you can solve your logarithm, the argument expression must be a positive number. Now this is very, very important, and you're going to apply it in answering some questions in functions and even some questions in logarithm itself. And that one is log. I have this. Now I'm going to talk about the base now. Your base, before you can solve your logarithm, your base must not be equal to 0, or your base must be greater than 1. Okay, for example, let me take my calculator and show you what I mean. Now you press shift, then you press this symbol. Oh, sorry, just press the logarithm symbol, this one. Okay, so let's press that one. So now let me put any number here. Let's say here is 5. The argument is 5. Now the base. Let's make the base 0 and see what the calculator will tell us. Math error. What about if I make the base 1? Can it solve it for me? Math error. Someone will say maybe the argument is because of the argument. Let's change the number. Let's make it it's still math error. So in other words, before you can solve your logarithm, your base must be greater than 1 and it must not be equal to 0. Okay, so your base must be greater than 1 and not equal to 0. Other than that, you can't solve your logarithm. Now, another important thing that you need to know is also let me show you the other one, the first one, this one, the previous one. What if my argument is a negative number, let's say negative one. Let's see what the calculator tells us. You see, we can't solve it. A reason. What if it's negative 5? You can't solve it. What if it's negative 1, negative 8? You can't solve it. So before you can solve your logarithm, your argument must be greater than 0. And when you come here, your base must not be 0, or it must also be greater than 1. All right, now another one. Log 1 to any base is 0. Hmm? Log 1 to any base at all is 0. Let's check with the calculator and see whether it's true. Logarithm of 1. No. Okay, let me change the base. What if it's base? Base 10. Does it change anything? What is base 20? Does it change anything? It doesn't change anything. So log of 1 is always what? 0. Okay. So if I have log, okay, we shall come back to that one later. And then logarithm of a number to the same number is 1. Logarithm of a number to the same number is always 1. This is very, very important. Okay. I'm going to use it. In fact, I'm going to abuse it in this topic. So please don't forget. Then another one. I think this one we have done it already, but let me see whether you'll be able to. Now, this is the same as, you see, we can apply the power rule. Your argument is raised to a certain power. The power will jump down. You remember that? So now this is the same as this. But don't forget that any logarithm to the same base is what? 1. So this is the same as what? K. Okay. I hope you don't forget this one. Another one. We call this one the inverse property of logarithm. Now it says that if I have, let's say, log b to the base b and the power is x, you know this is the same as x, right? That's why there's the there. Similar one. You know the power will jump down, so it's the same as this one is equal to x. Now, if you have a number raised to a certain power, and the power is actually a logarithm, okay, and the base here is the same as the base at this side, the base here. Now, the rule says, the inverse property rule says that the base and the base will cancel, this and this will cancel, leaving only what? The x. So the x will come here. Don't add a logarithm to it. Okay. So in other words, this is the same as, okay. So can we take an example? So example, if I have e logarithm of x to the base e, this is the same as x. The e and e will cancel, so it's left with x. Can we take another example? Let's see, if I have 5 to the power logarithm, this is the same as what? Can you guess? This is the same as 2. Say 2. Okay, so this and this will cross out. Another one, 16 to the power log x to the base 2. This can be 16 can be written as 2 to the power 4. Then I just bring this, and we say that your coefficient can become your power. This is like the power rule, like the reverse of the power rule. The reverse is also can also be done. Okay. Now, since the base and the base are the same, this will give us the argument. Okay. So this is not so popular, but it's it can help you to understand um, natural logarithm. Later on, we shall do natural logarithm, but I think I have to just mention something small about it. Let me add something. I'm almost done. Forgive me for spending too much time on this, but as I said, the concept is very important. I can't afford to leave out anything, otherwise it can affect you. So please permit me to spend a little more time on this so that you really understand when they give you any question, so that Cambridge cannot trick you with any question. Okay. Before I get to the natural logarithm, you should know that log m to the base 10 is the same as log m. So when they give you logarithm, they don't bring the base. That means it's to the base 10. And this thing is the same as lg m. So if you see lg, it is not a TV. lg here means logarithm to the base 10. All right. Another important thing that I think you should know. And before we go away, I want to talk a little bit about natural logarithm. Natural logarithm. Um, I will talk extensively on this topic later, but for now, I'm just giving just a brief knowledge about it. Okay. Now, any logarithm to the base e is called natural logarithm. Now, this one, the e here is a constant. It's called the Euler's constant. Euler's constant. And the e, the number is 2.718. Just like we have a constant like pi. Pi is equal to 3.14. The e there is a constant, okay? So it's a very popular concept of log to the base e. All right. So it's not every time that you get your base to be a whole number. It can also be e to the base e, which is 2.718. Okay, so this is an irrational number. All right, it's something special in logarithm. It's called a natural logarithm. So I just think that you should just know something later about this. I shall talk more about this later. But before I go, if you have if you have something like this, this one could be written as log e to the base e, which is the same as what? Which is the same as y. Why is it so? Because any logarithm to the same base is what? Is 1. And you know that from the power rule, the power here will jump down and become your coefficient. And don't forget that this one can be written as ln e to the power y. Okay, so that's something little that I think that you should know. So I'll end here. I believe this video has been very helpful to you today. If you like the video, don't forget to subscribe. Don't forget to tell your friends about this video, and also hit the like button so that YouTube will recommend the video for others. See you in the next one. Bye.